In the second video, we're going to be showing how to find inverse functions, okay? And the good news is, for a lot of different kinds of problems, you approach it the same way. Let's look at what's going on here. What's the relationship between x's and y's here? We're talking about relationships, yes. Excellent relationship advice from your math instructor. So, a lot of times we can write f of x is equal to y. I plug in an input into a function and I get an output. Now, what if we have that same exact thing, but what if we take f inverse of both sides? We are very used to doing things like this, right? Dividing both sides by 2, squaring both sides, multiplying both sides by 17, whatever. We're very good at doing something to both sides. Well, let's take f inverse of both sides. The left-hand side, by the definition of what it means to be an inverse function, they cancel each other out. The left-hand side is just an x. So if in a normal function, we plug in x and get y out, an inverse function does the opposite. Inverse functions, we plug in the y and we get the x coordinate out, all right? So this is going to be sort of the cornerstone of this video. Let's see this with example 2. If f of 3 is equal to 2, find f inverse of 2. So again, this is our x, this is our y. In a normal function, we plug in x, we get y as an output. But here, there's an inverse function. It goes backwards. Inverse function, we plug in the y, and we get x as our output. Well, if y is 2, what is x? X is 3. F inverse of 2 is 3. Another way to approach this is do what we did over here. Let's take f inverse of both sides. F inverse of f of 3 is going to equal f inverse of 2. And there's a specific reason why we can do this to both sides, but not really important unless you're curious, in which case I'll tell you. The left-hand side, they cancel each other out. F and f inverse, what are we left with on the left, is a 3. This is another way to see that f inverse of 2 is equal to 3, just like we said. Okay, so 2 ways of solving something like example 2. So, for the next thing, we're actually going to use the table from the book and do a variation on the homework problems there. Okay, so example 3, I'm going to refer to a specific table, right? And it's going to be the same exact idea, okay? If we have an input, f of that input's going to be an output y. We're also going to be going backwards if you ever have f inverse. And we're going to show a bit of a strange wording that happens in these problems with the book. I want to show that off as well. Okay, so let's look at this table. All right. We have a bunch of x's. And the function values are over here. Okay, so first off, if I ask you, what is, that's the wrong scene, what is, find, part A, f of 0. Again, 0 is our x, and we need to find our y. We consult the table, say, okay, when x is 0, what is y? Y is going to be 8. Right? X is 0, y is 8. That's our answer for part A, just like that. It's kind of a weird wording that the book says, solve f of x equals 7. And again, we want to know what is x when y is 7. So we consult the table. When y is 7, what's our x value? So we look at the y's. Function outputs, f of x, y. And they're synonyms, same thing. So when is the function value equal to 7? Right here. When y is 7, what is the x? The x is 2. We're going to say when x equals 2 as our answer right here. Variation on the same thing. Find f inverse of 7. Again, for normal functions, we put in an x and we get out a y. For inverse functions, we put in a y and we get out the x. So this is the same exact question as part B. When y is 7, what is x? Again, x is going to be 2. So two different ways of phrasing the same thing. All right. Or D, find f inverse of 1. So again, function inverses take in y values of the original function and spit out x values. So we have to find when is y equal to 1. Here's our outputs. When is it equal to 1? When is it equal to 1? It's equal to 1 right here. It's going to be when x is equal to 9. All right. These are all of our answers and how we approach these problems. Final thing for this video is that for inverse functions, really the fundamental thing of inverse functions is switching your inputs and your outputs. That's switching your x's and your y's. So if I need to find what an inverse function is for a given function, that's exactly what we're going to do. We're going to switch our x's and our y's. We're going to see that with the next example, example 4. Find f inverse of x for the following. Part A, f of x is equal to x plus 5. And you might say, Jason, you said we have to switch x's and y's. We don't have any y's. Well, don't worry, right? Y is the same thing as f of x. In almost every math context ever for most people, y and f of x are going to be the same thing. So let's just write it. Y is equal to x plus 5. Right, so this is our original function. To find the inverse, all you have to do is switch the x's and the y's. So that's a y. Let's say it's an x. That's an x. Let's call it a y. See how we just switched? Instead of writing x, we wrote y. Instead of writing y, we wrote x. So to find the inverse function, now all that's left with is solve for y. So we need to subtract 5 from both sides. We're going to get x minus 5 is equal to y. That's our inverse function. F inverse of x is equal to x minus 5. In this case, our function and our inverse function are both lines. This one got shifted up 5. This one got shifted down or right 5, depending on your point of view. Let's do some more complicated ones though. Part B is f of x is equal to, let's not do the worst one yet, 3x cubed plus 3. Again, we want to switch the y's and the x's. In order to switch the y's and the x's, we need to write it with y's and x's. So again, this is our original function. The inverse, just switch them. Y, not anymore. It's an x. X, not anymore. Let's call it a y. So that's going to be our inverse. And now we solve for y. So we subtract 3 from both sides. You get x minus 3 is equal to 3y cubed. Divide everything by 3. You're going to get x over 3 minus 3 over 3 is equal to y cubed. If you wanted, you could just write x minus 3 all over 3 as well. Different ways of writing this. Now we need to take the cubed root. Cubed root of x over 3 minus 1 is equal to y. Or, another way of phrasing that is that f inverse of x is the cubed root of x minus 3. Sorry, x divided by 3 over 1. That's our inverse function here. So again, let's talk about this. This is a function transformation of a toolkit function, x cubed. This is a function transformation of another toolkit function, cubed root of x. What's happening here? We're vertically stretching it by 3 and then moving it up 3. This is the cubed root function getting horizontally stretched by 3. Remember that inside things go backwards, so you might think horizontally stretched by 3 and then right 1 unit. All right? There's a relationship. Vertically stretched by 3, horizontally stretched by 3. And the reason why this is up 3 and this is right 1 and not right 3 just has to do with the order on which we're doing things. Okay. Remember there was that order I said, start with horizontal, end with vertical, do everything in between. We said that in 3.5. If you do things in different orders, they sort of switch things up, and that's what's going on here. Okay, part C, one more. This one's kind of nasty, but I wanted to show it to you. F of x is equal to 2x plus 1 over x minus 2. Or again, y is equal to 2x plus 1 over x minus 2, right? This is our function. So the inverse is when you switch the x's and the y's. Now something a little different happens here. Compared to the previous ones, I have 2 y's now, right? How am I supposed to solve for y when I have 2 of them? This is the same way that we solve for x's when we have 2 of those. We've done that all the time. So whenever you have a variable in the denominator, that's a problem. Let's get it out of there. Multiply both sides of the equation by the LCD, y minus 2. So the left-hand side, right, we have y minus 2 times x. On the right-hand side, the y minus 2's cancel, and we have 2y plus 1. So we still have 2 y's. Sorry, I should say, because we do have a 2y. We still have y's in 2 different places. But now we have no y's in the denominator, which is nice. I don't like fractions. Most other people don't like fractions either. So we need to get all the y's by themselves. Everything with a y, let's get it on one side. Everything without a y, let's get it on the other side. Well, there's this 2 over here. Not really attached to the y, but both of them are getting the x. We're going to really need to distribute that x. X times y, xy, minus 2x. Right-hand side's 2y plus 1. So again, we want to move this y over here and this not y over there. We're going to add 2x to both sides. And we're going to subtract 2y from both sides. Let's do things one at a time. xy is going to be 2y plus 2x plus 1. Let's subtract over that 2y. We get xy minus 2y is equal to 2x plus 1. So now all the y's are on one side and all the things without y's are on the other side. Now we can't just divide things out like you might want. We have to factor first. So if you take out a y, look what happens. Look what happens if we take out a y on the left-hand side. Now y only occurs in one place. And now we can divide out. Just like if we had 2y, we divide by 2. Well, we have y times this. Let's divide by that. Divide both sides by x minus 2. You're going to get y is equal to 2x plus 1 divided by x minus 2. Now, there's something very funny about this answer. We spent a fair amount of time getting it. This is our inverse function. F inverse of x is equal to 2x plus 1 over x minus 2. But I don't know how good your memory is. That's exactly what we started with. we did all this stuff, finding inverses, moving things around. We got the same exact function that we started with. This function is its own inverse function. Its inverse function is itself. It undoes itself. Much like a lot of people in the world, a lot of times we are our own undoing. Okay? So this is kind of a funny situation. We still solve it like normal. Kind of a funny little outcome. I bet you're laughing at home, ha ha ha, when you see that answer. Okay? You should be able to find inverse functions now. So go ahead and do those problems.